Using a 3D printer means having access to a 3D computer model that can be printed. When we started using a printer at school, we downloaded files from Thingiverse. And while that worked for a while, and there are many cool things to print, eventually you'll want to make something of your own design. To do that, you'll need to use a computer-aided design software, CAD. There are many different CAD programs meeting many different industry needs, but I've come to love TinkerCAD. It's a free, web-based program from Autodesk, which makes a lot of professional CAD software. Sometimes it can be clunky and lacks the tools to make compound curves, but it is super easy to use. It has great features for educators, and it runs on the underpowered Chromebooks my students have access to. Start by going to TinkerCAD.com, and if you are new, click Sign Up in the upper right. My students need to click Sign In at the bottom of the box, Student Accounts, and then sign in with their school-supplied Google account. As a teacher, I create a classroom and share a class link. This lets me go into student accounts, see what lessons they have done, help if they are stuck, or easily export files to print. I recommend new users click on the Resources menu on the top drop-down menu, Learning Center, and then under Learn 3D Design, click View All. Do the first 12 tutorials. Place it through camera controls. It's pretty quick, half hour to an hour, and you'll be a TinkerCAD master. I usually have my students try one other project like luggage tag before I give them an assignment. When students are ready to print, I go into their profile and export their project as a stereolithography file, .stl. This is imported into a piece of software called a slicer. I use Cura. It's free and powerful. This software slices the model into many layers to be 3D printed. It calculates the numbers of layers needed, the spacing of layers, whether the model is filled or hollow, and how exactly the print head of the printer needs to move. The software creates a new type of file called G-code that's basically a set of instructions for how the printer should move. That file is either sent wirelessly to our Ultimaker printer or saved to a card and inserted into the other printers we have. The printer is turned on and told to follow the set of instructions. There are limitations on how things can be printed. Prints start at the bottom, build a base, and work upwards. It can't print objects floating in the air, and even if an object is connected to another structure, it's difficult to print if there's nothing under it. These are called overhangs, and the plastic will droop and sag. The printer can plan for some supports, but this increases the time and material needed, and it's really hard to get off sometimes. It's better to minimize overhangs in the design. If the building needs big overhangs like eaves of a roof or a second-story deck, an easy solution is to design it in two parts that can be glued together after a print. Objects need to be connected in the model to print right. It's really easy to not have objects touching. The printer will make these separate pieces. Use measurements and look for gaps when designing. Little details don't print well. For buildings at the size we are printing, siding, roof shingles, and brickwork won't really show. Other details like the trim around a door or a window need to be exaggerated to print well. The printers are only so big. We can do 22 centimeters wide and up to 30 centimeters tall, but it's usually a good idea to make prints smaller than that. An object with lots of pieces usually benefits from printing each piece individually in the center of the bed. The quality is higher, and if there is a mistake, just one piece is ruined and not the whole set. One last thing for my students designing houses, we're just doing the outside. You don't need to create interior walls and add furniture at this point. Just work on getting the overall structure. That's the basics of designing in TinkerCAD and getting it on the printer. I will say, there's a ton more information on YouTube about 3D printing. I really like the videos from Maker's Muse and Thomas Sandlanderer, though I'm equally likely to break my printer as to make it better. Thanks for watching. I can't wait to see the awesome things that you design.